Welcome dear students. In last lecture we learned introduction part of sets and methods of writing the sets. Today we have to learn different type of sets. This type of sets are depend upon number of elements present in a set. To see details about that, first of all we see the various type of sets. Suppose I write here set A. A is the set of even prime number. A is a set of even prime number. Now this set I have to write in a list method. Therefore I write here A equal to, I have to write even prime numbers in a curly brackets, and if I start to write the even prime numbers, first even prime number is a 2, then afterwards there is no any even prime number, that means there is one and only one even prime number, and which is 2. Therefore this set consists of one element. And dear student, if a set consists one element, then that type of a set is called as a singleton set. Therefore first type of a set is a singleton set. You understand this very well, that is, if set consists of one element, then that type of a set is called as a singleton set. We can see the many examples of such type of a set. Suppose I write a set of set B is a set of even numbers between 2 and 6. Now tell me, between 2 and 6, how many even numbers are there? Suppose I write B, then between 2 and 6 there is one and only one even number, which is a 4. Therefore the set B also consists of one element, and therefore this set is of a singleton type of a set. Now we have to see the another set. Suppose I write here B is a set of natural number between 2 and 4. See, B is a set of natural numbers between 2 and 4. Now I want to write this set in a list method. Now tell me, which are the numbers between 2 and 4 and natural numbers? We have to write the number between 2 and 4, but that number should be a natural number, and there is one natural number between 2 and 4, and which is a 3, and therefore this set is also called as a singleton set, because this set consists of one element only. Now see the another example. B is a set of we have to write another set. B is a set of even natural number between 2 and 4. B is a set of even natural number between 2 and 4. Suppose I write here set B by using list method. We have to write even natural numbers between 2 and 4. Between 2 and 4 there is a one number which is a 3, but that 3 is not a even number, therefore there is no any natural numbers between 2 and 4, therefore this set does not contain element, therefore such type of a set are called as a empty set. That means when a set does not contain element, then that type of a set is called as a empty set. This empty set is also known as a null set, and this set is denoted by empty curly bracket or another symbol. This is known as a pi that we can use. Therefore, if the set does not contain any element, then that type of a set is called as a empty set. Empty set is also called as a null set. Now let's see the another type. Suppose I write here D is a set. D is the set of natural number up to 10. We have to write the natural numbers up to 10. That means we have to write set D in list method. We have to write the natural numbers up to 10. Natural numbers starts from 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This set contains 10 elements. We can count the elements. We can write down the list of these elements. That means elements of these sets are countable and they are limited, and then such type of a sets are called as a finite type of a set. Therefore we have to learn third type of a set. It is finite set. In this set elements are limited, they are countable, and this type of a set is called as a finite set. Always remember, the empty set is also a finite type of a set. Therefore, one most important property, empty set is also called as a finite set. In a finite set, the number of elements are countable as well as they are limited. That means when the elements are countable and limited, then such type of a set is called as a finite set. Empty set is also a finite type of a set. Now suppose I have to write the even numbers between 1 to 10. The numbers between 1 to 10, even numbers between 1 to 10, they are also limited and they are countable. Therefore such type of a set are called as a finite type of a set. We can see many examples. Now see, suppose I write here n. N is set of natural number. N is a set of natural numbers. Now all of you know the natural numbers. Suppose I write n in a curly bracket. I have to start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like this. The natural numbers are unlimited, that is not limited, and they are not countable. Therefore we have to put the comma and then we have to write 3 dots like this, and then such type of sets are called as a infinite. infinite set. Now you understood very well. When the elements are not countable, non-countable, and elements are not limited, then such type of sets are called as a finite set, infinite set. Now see again, these are four type of sets. These type of sets are depend upon the number of elements present in a particular set. Suppose A is a set of even prime number. This set contains one element. This set consists of one element, and therefore such sets are called as a singleton set. We see the another type of a set. B is a set of even natural numbers, but between 2 and 4. Between 2 and 4, there is no any even natural number. Therefore, such type of a set is called as an empty set. This set is also known as a null set, and for denote this type of a set, we have to use two type of these symbols. Then, D is a set of natural numbers. The elements are countable and limited. Then, such type of a set is called as a finite set. And remember, empty set is always a finite set. Now, n is a natural number, and set of natural number is always a infinite set because the numbers are uncountable and they are unlimited. Therefore, such type of a set is called as an infinite type of a set. In the first lecture, we learned sets of numbers. In set of numbers, we see the set of natural number. Then we learn the set of whole numbers. Then set of integers. Then set of rational numbers and set of real numbers. Dear student, all these five type of sets are infinite type of sets. Set of natural number, set of whole number, set of integers, set of rational number, and the set of real numbers. All these sets are of infinite type of sets. Dear students, in your book on page number 4, one table is given. Go through this table and write down this table in your book. Let's start with another concept of set. For that purpose, we have to see a pair of a set. Here I write A is a set of X such that X is a letter of the word listen. And another set B is given is a set of X such that X is a letter of the word silent. These two sets are in a rule method. We have to write it in a list method. Set A is a set of A is a set of X such that X is a letter of the word listen. That means we have to write the letters from this word. First letter is a L. We have to write L. Then put the comma. Second letter is a I. Third letter is a S. Then it is T, E, and the last is a N. There are 6 letters and we have written here 6 letters. Then we have to write the set B. In this set, B is a set of X such that X is a letter of the word silent. From this word we have to write the letter. First letter is a S, second is a I, third one is a L, then E, then N, and the last one is a T. Now observe these two sets which are written in a listing method. Here total elements are 6. This set B also consists of 6 elements. Now observe the each elements. Element L present in a set A is also present in a set L, set B. Afterward there is a I, and that I is also present in a set B. Then S is there, that S is present in set A as well as in a set B. Then T is the element of A, that is the element of B also. Then E present in set B. Then N which is present in a set B. That means both the set consist exactly same elements. Then such type of a sets are called as a equal sets. Now you understood, if two sets are given or more sets are given, and if we write it in a list method, and after observing listing method we came to know that the set consists exactly same elements, then that sets are called as equal sets. Now if we have to write it symbolically, we can write like this: A equal B. That means set A and set B are equal sets. Now let's see the another example, another pair of set. Here I write set P. This set P consists element A, B and C. Then set Q is there, which is in a list method. It contains 3, 4 and 5. These both set contain 3 elements. There are 3 elements in set P. Set Q also consists 3 elements. But both the sets contain not the exact same elements. Number of elements are same, but the elements are different. Therefore, these sets are not equal set. Therefore, we say that A not equal to B. That means set A and B are not equal sets. Therefore, when the set consists exactly same elements, then that sets are called as equal sets. Let's start with practice set 1.2, which is based on types of a set and concept of equal set. See the first sum from practice set 1.2. Now the first sum is given. Decide which of the following are equal sets and which are not. Justify your answer. Set A, set B and set C are given. From this given set, which sets are equal and which are not, that we have to write. Therefore, first of all, we write the given set. First set is given A is a set of x such that 3x minus 1 is equal to 2. Then second set B is given. B is a set of x such that x is a natural number but x is neither prime nor composite. and third set is C is a set of x such that x belongs to natural number and x is less than 2. Now these three sets are given and we have to decide whether given sets are equal or not. To find out whether sets are equal or not, we must have to write the sets in a listing method. Without writing listing method, we can't find out whether they are equal or not. Therefore, set first A is given, we have to write it in a list method. A is a set of x such that 3x minus 1 equal to 2. That means we have to, from this equation, we have to find out the value of x, and that value of x is the element of that set. Therefore, first of all, we have to solve the equation 3x minus 1 equal to 2. Therefore, 3x equal to 2 plus 1. Add 1 on both the sides, we will get this. Then it is 3x is equal to 3. Divide by 3 on both sides, we get x is equal to 3 upon 3. Therefore, x equal to 1. X equal to 1, that means set A contain one element, that is 1. This is statement number first. Set A contain one element, that is 1. Now see the next set, which is set B. Now B set, which elements are there? In set B, B is a set of x such that x is a natural number. But which natural number? Which is neither prime nor composite. The number which is natural number but not neither prime nor composite. And all of you know that 1 is the only number which is neither prime nor composite. Therefore, element of set B is 1. This is statement number second. Now we have to see the third set. C is a set of x such that x belongs to natural number. That means x is a natural number, and another condition is x is less than 2. That means we have to write the natural number which is less than 2, and there is one and only one natural number which is less than 2 is a 1. Therefore, we write here 1 is the only natural number which is less than 2. Therefore, we have to write the C set in list method. We have to write 1. Now this is statement number third, and now observe the statement number first, second and third. Set A contain one element, that is 1. B also contain 1 and C also contain 1. Therefore, we can write here from first, second and third, A equal to B equal to C. That means all these three sets contain same elements, exactly same elements. Therefore, set set B and set C are equal sets. Let's see the next sum. Decide whether set A and B are equal sets. Give reason for your answer. Set A equal to even prime number. Even prime number. Set B is given, that is B is a set of x such that 7x minus 1 is equal to 13. Now, as we saw in a first sum, we have to write the given set in a list method. Therefore, see the set A, we have to write it in a list method. Now, all of you know that we have to write the even prime number, and 2 is the only even prime number. Therefore, set A consists of element 2, because 2 is the only even prime number. Therefore, we can write here A is equal to 2. This is our statement number first. Now see the second one. B is a set of x such that 7x minus 1 is equal to 13. Equation is given and we have to find out the value of this x. The value of this x is the element of that set. Therefore, we have to write here for set B 7x minus 1 is equal to 13. Therefore, 7x is equal to 13 plus 1. Add 1 on both the sides. Therefore, 7x is equal to 14. Divide by 7 on both sides. Here x is equal to 14 upon 7. Therefore, x is equal to 2. Therefore, we write here element of set B is equal to 2, and this is our statement number 2. Now observe statement number first. Set A contain element 2 and B contain exactly same elements. Therefore, from first and second, we can write set A equal to set B. Therefore, both sets contain exactly same elements. Therefore, set A and B are equal sets. Now, see the next sum. Third one, which of the following are empty sets and why? 3 sets are given and we have to decide out of that 3 which is an empty set. See the first one. A is a set of A such that A is a natural number smaller than 0. A is a set of A such that A is a natural number smaller than 0. This set is given in a rule method. We have to decide whether this set is a empty set or not. For that purpose, we have to write it in a listing method. All of you know that we have to write the natural number smaller than 0. Students, you know that the natural numbers start with 1. Therefore, there is no natural number less than 0. Therefore, this set doesn't contain any elements. Therefore, this set A is an empty set. See here, we have to write there is no natural number which is less than 0. Therefore, set A doesn't contain any elements. Therefore, we write here set A is an empty set. Let's see the second. Set B is a set of x such that x square is equal to 0. X square equal to 0. Now see, B is a set of x such that x square is equal to 0. Here, x square is equal to 0. Therefore, x is equal to 0. Therefore, set B contains one element which is 0. And therefore, we can say that set B contains one element. Therefore, set B is not an empty set. Third set is given. C is equal to set of x such that phi x minus 2 equal to 0 and x belongs to natural number. Now see this set carefully. C is a set of x such that phi x minus 2 equal to 0 and second condition, x belongs to natural number. That means the element of this set is a natural number. But which natural number? The number by getting after solving this equation. Therefore, we have to write this equation phi x minus 2 equal to 0. We have to solve this equation. Therefore, phi x is equal to 0 plus 2. Therefore, it is phi x is equal to 2. Now, divide by phi on both sides. X is equal to 2 upon 5. We get the value of x is 2 upon 5. But x belongs to natural number. It is given. Therefore, the value of x we got it is 2 upon 5. But that number should be a natural number. But 2 upon 5 is not a natural number. Therefore, C set does not contain element. Therefore, C is an empty set. Therefore, C is an empty set. Therefore, A is an empty set, B is not an empty set, and C is an empty set. See the question number 4. Write with reason which of the following sets are finite or infinite. Some sets are given and we have to decide with reason which are finite and which are infinite. Set A is a set of x such that x is less than 10 and x is a natural number. A is a set of x such that x is less than 10 and x is a natural number. That means this A is a set of x. That x has two properties. First one is it should be a natural number and less than 10. Therefore, we can write here the set in list method natural number less than 10. That means 1, 2, 3, 4, 5, 6, 7, 8 and 9. We can't write 10 because we have to write the number which are less than 10. Now these elements are countable, they are limited, therefore we can say that set A is a finite set. We write the set in a list method. The elements are countable and limited, therefore set A is a finite type of a set. Second is given B is a set of Y such that Y is less than -1 and Y is an integer. Now see, B is a set of Y such that Y is less than -1 and Y is an integer. We have to write the integers which are less than -1. We can write it. All of you know that integers here we can write -4, -3, -2 like this. This set consists infinite number of elements. Therefore, we can say that set B is an infinite set. It contains, remember, when we have to write infinite type of a set, we have to put exactly 3 dots. Now let's see the third one. Now see the third sum. C is set of student of class 9 from your school. Now we have to write the elements of set C as a student of class 9 from your school. The number of students of class 9 from your school are countable, therefore it is a finite type of a set. Number of students of class 9 from your school are countable. Therefore set C is a finite set. Now see the fourth one. Set of people from your school. The fourth one, set of people from your village. We can count the number of people from our village, therefore this set is countable and therefore the set is a finite type of a set. We have to write here number of people from your village are countable, therefore given set is a finite set. Then we have to see the question number 5th one. In that, set of apparatus in laboratory. 5th one, set of apparatus in laboratory. In our laboratory, how many apparatus are there? We know that, therefore numbers of apparatus in laboratory are countable, therefore given set is a finite set. See the sixth sum, set of whole numbers. All of you know that set of whole number. Whole set of whole number is denoted by W, and we can start with 0, 1, 2, 3, 4 and so on. They are not countable, uncountable. Therefore, this set of whole number is an infinite set. Therefore, set W is an infinite set. And there is one more sum is there, set of rational numbers. Now, seventh one is there, set of rational numbers. Now, set of rational numbers. There are infinite rational numbers. Therefore, we can write here rational numbers are uncountable. Therefore, set of rational numbers is an infinite set. Dear student, I hope everyone understood practice set 1.2. Write down all these sums in your notebook. Thank you.